Now see your Wheatstone principle. We will be using your Kirchhoff's law to derive this principle. Suppose you have got 4 resistances P, Q, R and S. They are arranged in the form of the bridge as shown in the diagram. Suppose there is here P and here is here that is Q, and then there is resistance R, and then here this resistance is S, and there is a galvanometer connected here of resistance this capital G, its resistance is capital G, and now there is a tapping key. Here we can take K2. Now these two parts of this, here two ends are connected to a cell of EMF here E and having internal resistance 0. This point we can take A, this is here B, and this is here C, and this is here D. Now see, the value of the resistances are arranged. Resistances means P, Q, R and S are arranged in such a way that the current through the galvanometer is 0. So when the current through the galvanometer is 0, then we say bridge is balanced. So now what is the relation between these 4 resistances when the bridge is balanced? So this is actually the principle of the Wheatstone bridge. So now we can take the distribution of current. Suppose current I is coming from the cell, this is the junction point here. We can take current I1 to this side. So this side is I minus I1, and here it is coming I1. Through galvanometer it is going Ig. So this side it is here I1 minus Ig. Say here, take care, distribution must be correct. This is here tapping key, the circuit is closed now. From the galvanometer side it is coming Ig, and from this side it is coming I minus I1. Both are getting added at this junction and going to this side, it is I minus I1 plus Ig. And again at the point B the total current is I. So see here, the current here, distribution of the current must be here proper. So we can take the two different loops and apply Kirchhoff's law. Suppose you are taking the loop ACDA. This is actually we are going in the clockwise. So first we go A to C in the direction of current, that means higher potential to lower potential. So difference we can be written I1P negative. In galvanometer C to D also we are going to in the direction of the current. So we can write minus Ig into capital G. Capital G is the resistance of galvanometer. And here now D to A we are going opposite to the current, lower to higher potential. So we can write I minus I1 into R is equal to 0. The loop is closed now. Now similarly we can take the loop CBDC. Here also we can write C to D. In the direction of current, this is I1 minus Ig into Q. This is the minus sign here. B to D, that is opposite to the current, that is the positive here. So plus S into I minus I1 plus Ig, and again D to C opposite to the current. So plus Ig into G is equal to 0. So these are the two equations we have got. But see here, in the balanced condition, when the bridge is balanced, current through the galvanometer is 0. So now we have to put in these equation Ig is equal to 0, and now then solve these equations. So if you are taking Ig is equal to 0 in these two equations, so if I write Ig is equal to 0, so this one will become minus I1P, this is 0. So plus I minus I1 into R is equal to 0, and we can write I minus I1 into R is equal to I1P. This is the first equation. If you put this in this equation, you will be getting minus I1Q and plus Si minus I1 is equal to 0. This term will be 0. So we will be getting here I minus I1 into S is equal to I1 into Q. This is the second equation. Now say here, divide first by second. So if you divide the first by second, you will be getting R by S is equal to P by Q. So in this case, when the bridge is balanced, that means no current is flowing through the galvanometer, then the relation between the 4 resistances which we took in the bridge are this one, P upon Q is equal to R upon S. So, now see here, this is a meter bridge or the slide wire bridge here. By using this bridge, we can calculate the resistance or the resistivity of the given wire, and it is working actually based on the principle of the Wheatstone bridge. So, let us understand its construction here. There is a wooden board here, this one. This wooden board has got a scale of 1 meter 0 to 100 divisions, and there is a wire, 1 meter wire is stretched between these two ends. This wire is made of manganese or Constantan alloy, and there are the copper strips here. This is horizontal board and these are the copper strips. With the ends of these two here, in this gap a resistance box is connected, and in this gap a wire is connected whose resistance has to be measured. Resistance or resistivity also we can measure. So, suppose this wire has got the end point here X and Y. At this point there is a galvanometer here connected between this point, and the another end of the galvanometer is connected to the jockey. Now, between the wire A and B, a battery cell is connected here of EMF DC, and a key is here, it is connected here. When this switch is closed, current flows from this side and it comes to the this end, one part goes to this side, one part goes to from this side, and again they come and combine here. Now, the when current is flowing from here, we take out some resistance from this resistance box, we apply some resistance from here, and we take this end jockey. This jockey is placed first over here, and then the deflection of the galvanometer is seen. Then the jockey is moved from here, it is not actually slid over the wire. So, when we place the jockey somewhere here, galvanometer shows null deflection. So, we get the condition for the null deflection. So, when the galvanometer is showing null deflection, suppose this point AJ, this is here suppose length L. So, remaining part JB, this is here 100 minus L. This we can take as resistance P, and this JB we can take resistance Q. So, this is here R and this is here S. Suppose the resistance of the wire AB, resistance per unit length of the wire AB be R, then we can write the resistance of AG, resistance of AG is equal to LR, and resistance of JB, AJ and JB are actually the two parts of the wire AB. Jockey has divided actually by placing the jockey. So, JB is equal to, we can write 100 minus L into R.